Good day everyone, this is Vlad Kustov again with a new video about covariant tensor machine. Today I tell you about the CTM in special relativity, the case of pseudo-Euclidean space. From past video it was well known that the CTM is the graphical and analytical method that defines the connection between vectors in general. The goal consists of the searching head vectors in space-time and connection with them. Let I have two reference frames, 0 and 1. Every system has proper time that to determine as CT and CT wave vectors. These frames separate the action space interval of module x t small t 0 lower index and small t 1 lower index are initial moment of time each reference frame 0 and 1. After the expiration moment of time big T and big T wave, the time distance are equal CT. In this place it's worthwhile to consider one of traditional Einstein postulate. It tells us the principle of invariant light speed. Light is always propagated in empty space with a definite speed c, which is independent of the state of motion of the emitting body. Based on it, I can suppose that exists a restriction on invariant of vector. In other words, I have restriction on maximum length of vector. In this case, module CT and CT wave are maximum time distance. If distance between 0 and 1 are constant, in this case, then partial derivatives are equal 0. Therefore, the modulus of equal each other CT and CT wave, and vectors CT and CT wave are parallel. And one else condition in CTM theory: actual distance modulus x less or equal CT or CT wave, and time of one-step machine is 1 second. In special relativity, CT and CT wave is the proper time of reference frame 0 and 1. Every reference frame has the proper time. Now, I have two reference frames, first and second, and the actual distance is equal 0 in initial moment t0 lower index is equal 0 second. The vectors of proper time, first and second, are collinear and have the same start point. First is a rest reference frame, relativity of second. Its actual velocity is 0. Point second is a moving system that has actual velocity vector vd upper index. From past video about CTM can recognize that velocity is possibility a moving per time equal 1 second. Then I have equality of modulus between distance and velocity. In its place, it's worthwhile to consider the dot product of basis vector are zero. Therefore, directions, current time, and actual distance are perpendicular. It's accepted because frame 1 and 2 doesn't have curvature force fields of interaction. One more thing, in this place I don't know the scalar function of connection between actual velocity or actual distance and time distance. It's well known that actual velocity is opportunity and time distance vector always exists in its proper frame. In other words, Ct doesn't depend from another frame, and addition the velocity to another frame doesn't influence on Ct. In addition, it well known velocity of reference frame is a vector attached to point. If that is the case, then actual velocity of second reference frame shows the point where will be system in a second. At that same time, the reference frame has vector speed of light on time distance direction. It exists always. Now my goal sums up to vectors actual velocity and speed of light. I have known that in this spacetime is restriction on invariant of vector and all action occurs in 1 second. I have had speed of light in maximum in spacetime. Nevertheless, I have actual velocity and further effects of addition reduces to contradiction in principle of invariant light speed. For that reason, vector of actual velocity rotates the vector speed of light relativity start point. This event occurs in accordance with determination of velocity vector and the principle of invariant speed of light, but the total vector S isn't vector speed of light or actual vector. S vector determines spacetime attitude between actual velocity and speed of light. In other words, S is spacetime invariant that contains information about actual velocity, speed of light, and other values. Now, S vector can correlate with fixed reference frame. First, connection between first and second reference frame is a scalar function. It's circle. It because exists rotation of vector. Such circle or scalar function is named absolute. Absolute of spacetime is the scalar function that applies restriction on invariant of vectors. In that way, I have search decision of goal formally. I know connection between time or time distance ct and any actual velocity or distance x. Absolute is a 1 second speed of light or maximum distance per second. Now I explain how CTM lives in spacetime. In this case, I have one dimension of space and time dimension. One dimension of space can be represented as the composition of three vectors. For this necessary, we will determine metric tensor. Vector of time distance is an isotropic vector that has only one generalized direction. In other words, its vector flux of time. Et is a basis vector of time direction. It's always positive vector. Actual velocity vector has two generalized direction concerning vector of time distance. It's plus or minus. Ed is a basis vector of actual velocity or actual distance. Ed direction I paint a dashed line because actual velocity can be zero, but a vector of proper time distance always exists. Here, necessary gives the determination of generalized direction. Generalized direction is a direction the same with direction of basis vector. Later, I will produce video about the use in CTM for a determination metric tensor. It's a complicated theme that concerns fundamental forms. Now, it's worthwhile to consider the structure of vector time distance Ct. I have known that Ct is a vector of time fixed reference frame. It consists of two vectors of time. They are vectors of a moving frame and vector of time dilation. In that way, Ct is the dative sum of vectors. Vector of time dilation, that is time difference between moving reference frame. It lays overboard of absolute. The space overboard of absolute is named spacetime vagueness. Ct, small t upper index and 1-2 lower index is a proper time in moving reference frame. Ct, small t upper index and 1-2 lower index is measured by fasten clock with it. Also, vector diagram of time can be considered as a space of differential form of time vectors. In support of my words, I will receive Lorentz transformation for relativity of time and get the Lorentz factor and proper time in moving reference frame. Spacetime invariant S is vector that can be put as components, where x is equal. While I don't know about basis vector with the exception of direction and scalar function, that restriction on invariant. Another side, I have known that modulus S is equal module of vector proper time fixed reference frame. Then I can write next expression defines the relation with two reference frame. It's written from right triangle. The invariant of vector actual velocity is a given vector. The frame two are having it. Necessary distribute the required and known values Using algebraic way, I get next expression where gamma factor is equal square root from expression. If vector of actual velocity is equal 0, then diagram changes into identity proper time distance ct and s. From now words, s is equal ct. Such picture is characteristics for rest reference frame. In that way, CTM gives a distribution of time in moving depending on actual velocity. If reference frame reaches nearby speed of light, then time distance vector of a moving frame becomes 0. In other words, when observers are in a moving reference frame, they see actions in rest reference frame as fast moving. For rest observers, it's against picture. Rest observers see actions in moving reference frame as a slow movie. Here, the CTM gives a clear understanding event about relativity of time. CTM saves Euclidean space, but with restriction of invariant. It means that perception of physical events will be more easily. I have answered the question how CTM lives in space-time. Now I can see twin paradox visually and have the opportunity to explain this event more simply. Here are the same action reference frames. One is a rest system or rest observer. Two is a moving reference frame or a moving observer. In rest reference frame goes 3 seconds. It's full time of rest system. Rest frame moves along only time direction. It's because actual velocity is equal 0. Simultaneously, the moving reference frame has actual velocity. Values adds up to produce full actual distance. It gives the effect of time dilation that written early. Here, process has been expressed on many times. I think that picture shows rather than I talk about it. Here at once I can see how past connection with future and where is present.
The CTM is another expression of Lorentz transformation. Formation of absolute gives the opportunity to conjecture about existence of chronon. It's quantum of time, but this is a question other using of CTM. In next video, I will show you how actual velocities add in spacetime, and I will receive velocity addition formula for relativistic speed. I will have done it with CTM. I will show you a new point of view on spacetime and theory of special relativity. There will be additions and adjustments about causality principle in theory CTM and principle list of action. Thank you for your attention. See my next video about development theory of CTM.